Okay, so the reduction formula here, where in is the integral from 0 to 1 of x to the n sin x dx, and I'm going to show that that reduction formula is this. So product and integration by parts, I'll reduce that power of n by differentiating, so u is x to the n and dv is sin x. So du is nx to the n minus 1, and v is integral sin x, which is cos x. So du dv is uv minus integral v du. So in is going to be, right, uv is x to the n cos x from 0 to 1 minus integral of v du, which is take the n outside, x to the n minus 1 cos x dx. Well, and this isn't in terms of an in structure, okay, because I need a polynomial in x and I need a sinh function. So I got polynomial in x and a cos function. So I do the parts again for this integral. It'll come back round to a sinh. So I'm going to consider this bit here, and then come back and sub it in. So consider the integral of x to the n minus 1 cos x dx, and that's limits from 0 to 1. So u dv, so u is x to the n minus 1, dv is cos x. So differentiating, so du is n minus 1 x to the n minus 2, and v, if I integrate cos x, I get sin x. So using the formula then, so that's going to equal uv, which is x to the n minus 1 sin x from 0 to 1 minus the integral of v du, which is n minus 1 x to the n minus 2 sin x dx from 0 to 1. Okay, just rewrite then the second term here. Take the n minus 1 outside. I get that. So what's in the box there is this expression. So I now need to come back to here and multiply all of this by the n. So I got in is x to the n cos x from 0 to 1 minus n times x to the n minus 1 sin x from 0 to 1 minus, and this is full bracket there, n minus 1 integral from 0 to 1 x to the n minus 2 sin x dx. Well, right, let's get all the terms separated out first. That's 0 to 1. Right, multiply this one there, so this is minus n x to the n minus 1 sin x from 0 to 1. Double minus, that's a plus, n minus 1, and this is in minus 2. It's the same structure as in, only the power now instead of n is n minus 2, so that's in minus 2. Okay, when I put the limits in, if you notice there, they got cos 1, sin 1, so they haven't evaluated what they are. So in, right, so this one put 1 in, so that's 1 to the n cos 1, minus put 0 in, so that's 0 to the n cos of 0, minus n, put 1 in, so that's 1 to the n minus 1 sin of 1, minus 0 sin of 0, plus n minus 1 I n minus 2. Right, 0 to the power of n is 0, 0 to the power of n minus 1 is 0. 1 to the power of n is 1, cosh of 1 is just cosh 1, minus n. At 1 to the power of n minus 1 is 1, and sinh of 1 is 1, plus n minus 1 I n minus 2, which is what it's asked me in the question. Okay, the second part wants me to evaluate I4, and then the second part, even if you do the first part and can't get that reduction formula out, you can still use it and those 5 marks are still available to you. Okay, now then, for part B, and I want I4, so looking at this, if I put n equal to 4 in there, I'm then going down to I2, and if I work out I2, I'm going down to I0, so my first job is to evaluate I0. So I0 will be the integral from 0 to 1 of x to the power of 0 sinh x dx. X to the power of 0 is 1, so that's the same as the integral from 0 to 1 of sinh x dx. Integral of sinh x is cos x from 0 to 1, and then sub in, that's the cosh of 1 minus the cosh of 0, and cosh of 0 is 0, so that equals cosh 1. So now use the reduction formula, put n equal to 2 in the reduction formula. N equal to 2, and I got I2 is cosh of 1 minus 2 sinh of 1 plus 2 times 2 minus 1 is 1 I0. So I2 is cosh 1 minus 2 sinh of 1 plus 2 I0, which is cosh 1. So that's I2. And then if I put n equal to 4 in, I got I4 is cosh 1 minus 4 sinh of 1 plus 4 times 3, and putting 4 in there is I2. So I4 is cosh of 1 minus 4 sinh of 1 plus 12 lots of I2. That's 12 lot of this expression then. That's cosh 1 minus 2 sinh of 1 plus 2 cosh 1. You can see there I could have collected the cosh 1s there together, but I collect it all together at the end now. So I4 is cosh of 1 minus 4 sinh of 1 right, I've made an error. Going back up to I0 here, I've made an error. Cosh of 0 is 1. Okay, if we draw the cosh graph, that passes through 1, so the cosh of 0 is 1, so that's minus 1 there. So when I put in for I0 here, that's 2 lots of I0, so that's 2 lots of cosh 1 minus 1. And when I put in here for I2, so that's cosh 1 minus 2 sinh 1 plus 2, and that there is cosh 1 minus 1. So let's expand that there. The reason I picked that up there is when I'm looking at the format of the answer, there was a plus c at the end there, a constant, and I wasn't going to get that, so just double back on myself there. Right, so it's plus 12 cosh 1 minus 24 sinh 1, and here I got 12 to 24 plus 24 cosh 1 and 24 minus 24. So I4, right, how many cosh 1s have we got? I got 1, 13 and 24 is 37, so I got 37 cosh 1 minus 4 minus 24 is minus 28, sinh 1 minus 24.